the labs, and after we finish all the training that you guys wanted to do, finish all this, and then you can just say, you know what, it's okay now. I can just go ahead back and deactivate my account, or maybe delete all the instance and everything. I don't really need it anymore, and remove my credit card, and that's it. Thank you much. So you learn for free for 3-4 months, and you practice for free. And again, the thing is that we can do here in the free tier is really unlimited. Okay, so if I wanted, as I explained to you yesterday, if I wanted to implement, you know, application firewall, which is WAF. Okay, we don't have a lab for WAF, and we cannot ask you to go and purchase WAF to do a lab. But in here in AWS free tier, you can have WAF, and you can install WAF, and you can play with the policy of WAF, and you can also monitor the traffic coming over WAF. So I told you guys, we can build our web application, and on top of this web application, we can add WAF and start to really attack this web application, okay, and see how the WAF would protect this against maybe SQL injection or cross-site scripting. So this is really an advanced, it will build an environment like this in your computer. It will take us really long time. So we can just play around with AWS right now, and we learn also. We learn because it's not only playing around. Will be beneficial for you, inshallah, if you go and work in a big environment. Okay, so what is the schedule for today? So the schedule for today is going to be a topic called hardware assurance, and the hardware assurance will be covering something called supply chain risk. I have already explained that's one of the topics that we didn't cover from the NIST cyber framework is cyber security supply chain. So today we'll explain what the supply chain is all about, what kind of attacks that can happen in the supply chain, and also we were looking at also certain technology like HSM and TBM as well in the same lecture. So if we have the time, we will really cover all this. And the second part of the lecture will be covering, if you guys allow me, we'll be covering also something that we can do in the web, including something called VPC, and what is VPC is all about, and how can VPC can assign for you an entire data. I would say it's an entire data room inside a certain cloud region, and how you can divide this VPC to multiple subnets, and how can you assign different different permission to certain different subnets. So this is, inshallah, we'll cover it in the second part of the lecture. Okay, for the meantime, this is going to be the topic for today. Let me show you guys around here in the hardware section. If we go to our coding dojo, you can see over here, guys, the hardware assurance. It talks about supply chain attacks. So we'll explain some of the attacks that can happen, whether it's software or hardware one. Okay, we will look at also the trusted platform TBM, why we're using TBM in some computers and on most of our new mobile system, why they're using TBM. Okay, and we also will look at the hardware security model, HSM. Hopefully by this time we will have a little bit of time to look at the firmware and what is firmware means. And then in the lab afternoon, Dr. Asad will show you Security Onion and how to really deal with alerts on Security Onions. The second part of the lecture is talking about bring to your own devices. I think we have already covered this in so many occasions. But again, if you guys wanted really to read it here again one more time, it's over here. We can really look at the merits and the disadvantages of bring your own disaster. Okay, so far so good, guys. We clear about what we have. Okay.
Yes, Mr. Shadi.
Okay, and we have an optional lab for you guys today. If you wanted to do it, is a very easy lab. How to configure TBM in your computers and why TBM are used in your computers. So this is something we can do it as an optional lab. If you finish the Security Onion, if you have some free time to do it, it's very good. Also, I have another lab for you guys if you wanted really to have like really extra work when it comes to when it comes to virtual cloud or AWS, I have by end of today, I have a small lab over here in how to really create different subnets and connect all the subnets with a router and connect this router to the internet or or to the basically the internet gateway and have this routers, how these subnets talk to the internet and see how this works. So this is also an extra setup. This is how it looks like in a very simple way. And this is how I can reach to a complete design for my network. I have divided my network to two parts. Part of them are private network, part of them is public networks, and we can see how this works. So this is actually also an optional lab for you guys to do today. And again, I wanted you to be capable in AWS to implement a whole solution. You implement your own web server, you implement subnets, you implement your VPCs, you create a security group, you create access control list in the AWS. So this will give you a lot of insight how AWS works. So this is all the topics that I'm, inshallah, will try to cover today as much as we can. So for the time being, we just let's start with our topic for today. I have already added this slides already in Discord. So if you guys wanted to really watch the same thing and have the same thing right now, it will be shared in Discord. It's already shared in Discord, sorry. So where we are right now from, we have started this course long time ago, and we talked about identity and access. We talked about that we will really need to follow a good standard to build our security program. And one of these good standards that's over there, sorry about this. Did you guys raise your hands so we can take the it's time? Oh, it's 8:15 now? No way. Okay, so you guys, Abir, you are good with attendance? Hello? So, okay, so without further ado, let's go back here and look at the supply chain, the cybersecurity framework. And as I mentioned, the cybersecurity framework is a good framework that started in the US in 2014. And the whole purpose of the cybersecurity framework is to build your information security program in a really organized, professional way, okay? So it tells you that you have 5 core functions, and under these 5 core functions, there is subcategories, which is, there is a categories, which is 22 categories. And under these categories, we have almost 100 subcategories, okay? If you are able to follow all these, categories and subcategories, then you will have like a full, complete security program that will be able to make your organization or cybersecurity resilient, or it will give you some sort of, I would say, capability to respond and to be able to withstand a cybersecurity attack. Okay, that is the whole idea. How can we look at this program? As I mentioned, there is identification phase, and the identification phase is all about, you know what is your assets, you do your assets discovery, you figure out what information you have in these assets, you interview people within the organization to understand where is really the crown jewels, what is really important in this organization to protect and really to ensure security for these. So basically, you are trying to understand the environment you are really working at as much as you can, okay? Because not everything that they will tell you, you'll be able to understand, but just being persistent and try to understand what systems, what information there, how these systems are interacting. So then there's another also dimension of, we didn't talk about it a lot, but there is something called about data flow, how the data flow really leaves one system to another system, and so on and so forth. So this is also very important. The idea here, guys, if you really doesn't understand your environment, you will not be able to protect this environment. Again, the role model here, if you cannot see, or you not understand, or you cannot visualize, you will not be able to protect. And that's why in so many cases, network diagrams, network topology, data flows diagrams will give you an idea what's happening inside your organization, which servers talks to which server. Is it normal to have a server talking to the outside? Why it's talking out to outside? This is really important to understand. So this is all in the early beginning. So you understand the business, you understand the requirement, you understand what is important and critical for this business, and then you look at this assets from the perspective of what is hardware involved, what is the software involved, and really look at also vulnerabilities that exist in this environment. And that's why a couple of days ago we covered something called vulnerability management, and we talked about vulnerability management in deep details. And the vulnerability management we mentioned, it's a process, and this process is including identification for the assets, data information management, and then risk management, and how these all are connected until it gives you the risk score, our vulnerability scores. And these vulnerability scores, we can really use it to plug it into our risk equation and have a complete picture of the risk. And then later on, we can really identify what is really high priority risks and what is medium and what is low, and we give a severity, and then we really inform the business about these kind of risks, and then we will be allocated a budget to really implement some controls. So this is really important, okay? And here, guys, what we really didn't talk about, and this is the risk management strategy, means that how you really respond to a risk. And we mentioned this is the risk treatment plans that you have, whether you're gonna do avoidance or whether you're gonna do a transfer, whether you're gonna do reduce or mitigate the risk to the acceptable level or to the tolerable level for the organization. And we also mentioned that lastly, we can really accept the risk if the risk is really not high for my organization. So this is also, we have covered this in the deep details. Okay, so what is this all about? Supply chain risk management. Okay, why supply chain risk management, okay, is becoming a thing right now. Okay, and how the supply, and what is the supply chain to start with? What we mean by supply chain. Okay, so we mentioned before, guys, before I just go in details and explain the lecture, I just wanted to tell you we are a consumer of IT equipment, okay? Whether this equipment is a hardware or a software, we are not manufacturing anything, okay? And if you really deep looking at your software, okay, or your hardware within your even laptop, okay, you would be really amazed by how many companies they were involved in just making this laptop or making any software that you use. Okay, so for example, I will just give you an example. So let's say that you have a laptop, and you started to really dig into the component of this laptop. Even this laptop is maybe an IBM or a ThinkPad, or maybe it's Dell, or maybe an Asus. There's so many manufacturers, but if you start to get every component alone, you will find that, for example, the camera coming from Logitech, okay? The first question you need to ask, is the camera and the software driver for this camera are being built in a security in mind or no? Okay, so this is the first thing, because if the camera and the software that manage this camera are not really secure, that means someone later on will find a vulnerability in this software or in the camera hardware, and then it can exploit it. So this is, you need this kind of question you need to have, and I'll explain why you need to ask these questions, okay? And what is the risk of having this kind of thing? Okay, you need to understand also the motherboard that you have in your laptop. Okay, whether you're using an Apple or using maybe another vendor like Dell or whatever. Okay, is a motherboard that comes in your laptop, does it really coming from one single manufacturer, or it's coming from a different manufacturer? What I mean by this, you have one motherboard that's been created by one factory, but every single component in this motherboard is like some CPUs, something like a memory. Is a memory also created in the same factory, or it's coming from a different vendor? Okay, and if it's coming from a different vendor, did we really look at the security when they creating and really doing the manufacturing of these component? Because end of day, this is could be like an entry point for attackers. Okay, we have all of us, memory, CPUs, different, capacitors, different things in the motherboard, and different chips. All these chips that are maybe a Bluetooth chips or maybe even a network card, okay? These are all coming from all manufacturers, different manufacturers, and how secure these manufacturers is. So this is kind of question that I wanted you always to look at. Okay, if we talk about this, and when it comes to really, hardware, we can talk the same thing about software. Okay, some software that we are using in our computer right now, like Zoom. Okay, how secure is Zoom is? Okay, this is because Zoom is going to be part of my equation of security. Okay, do I trust Zoom? They are like a company. They are doing a very great job when it comes to security, or no? Okay, because if they are not doing very good good job in security, and I install their application on my system, now the risk of being exploited is higher. Because why? Because then I open the door for attacks. Okay, so this is kind of question it's always comes to my mind when we look at the supply chain security. So without further ado, let's look at what makes us really started to think about this. So in our agenda for today, we start to look at what is the definition of supply chain, okay? What we mean by supply chain. Now, in a very simple way, guys, without complication, because, in order to really understand what is supply chain, if I have 2, 3 companies, or 3, 4, 5 organizations, they are working together to deliver a product for you, this is called the supply chain. Okay, so an example, in a very simple physical example, let's say that you got a bottle of milk today. Okay, how did you really get this bottle of milk? Okay, so this is your bottle of milk. I'm sorry about the drawing is really bad. So this is okay. Let me just do this bottle of milk of Marai. Okay, will make more sense. So this is the bottle of milk of Marai. Okay, and how did we get it today? Okay, so this is really a good example. So okay, so first of all, we have one organization, guys, that's really in Marai, and they are selling these products, right? But in order to really get to the supermarket, we have to use a company to distribute this, okay, to the supermarket, okay, and then you can buy it from the supermarket. But there is things that we don't really see about, we don't know about it. First of all, in Marai, we also do have a farm, okay, and this farm where you have your cows and your different type of animals there that they are really used to get the milk and cheese and all the stuff, and also these things are connected to maybe a farmer, okay, and where the farmer will just have an agricultural land, and then he will send El Marai some some crops to for the animals to feed at. Also, you will have someone over there, okay, who create different type of medicine, because I really need the medicine for the animal to make sure that the animal is not sick or whatever. So I need a vet or some sort of this. And also I really need someone who create different type of vitamins for these animals. So these animals are taking vitamins and stuff. So all of this stuff are part of the supply chain. So I'm give you an example. For example, if you have this farmer are not sending the crops, okay, that means the animal will not be able to produce the milk. Then Marai will not be able to ship this milk to you, and then you will have a shortage in milk. And this has happened already. Don't say this didn't happen or you didn't notice. Maybe you didn't notice in Saudi Arabia, but during the Corona beginning time, there's something similar happened. Why? Because we broke this delivery thing. Okay, so the delivery is broken, so the milk was really was not really delivered. So this is what we call supply chain. Okay, so the supply chain we have things from different organization, and all of them are relying with each other until we reach to the final product, which is the bottle of milk. Okay. And also don't forget that also this guys who's delivering, this is big company for delivery as well. This is another organization that we use to deliver this stuff. Okay, so this is when it comes to supply chain. Another also term and condition. Okay, if we have a software, okay, we are using the software right now in Zoom. Okay, like Zoom. Okay, I'm just giving you a Zoom as an example, but this can be any other software. So we have Zoom right now, okay? But before Zoom, we have another company here, okay, called Zoom, is the one who is actually distributed this application, okay? So Zoom is distributing, but we really didn't see what happened in order to create this software. So maybe they outsourced a company in India to build the source, to build the code, okay? So we didn't see the link over here. So these guys in India, or maybe you name it, any other country, they are well known for developing software for a cheap price. They are the one who developed this. So Zoom, they outsources this to another company, and even this company in India, maybe they have an outsources to individual to start to build parts of this project. So this is also a supply chain, okay? And we need to make sure that this supply chain is secure in order really to get a product which is secure end of day, okay? Because if one of these area was disrupted by any means, what will happen is we're not gonna get Zoom updates anymore, because maybe this company in India went bankrupt. So the Zoom itself need to go and find another distributor, another outsourcing place to really to build new updates for the system. So this is what we call supply chain in IT, okay? Same thing in hardware, okay? We have a computer for Intel, or maybe a laptop, or maybe a device like an iPhone, okay? We have iPhone in our hand, but how many countries were really involved to really manufacture this iPhone, okay? You can see this, the factory itself is in China, okay? But where is the components in the iPhone are coming from? You'll find that it's coming from Taiwan, okay? And where is Taiwan getting their raw materials from? Like the silicon, or maybe they're getting the silicon from another country. So it's where all connected, okay? And we need to make sure that all this connected chain is really developing these devices with security in mind. Otherwise, these devices, end of day, will not be secure. And I will give you a real example that's happened in the US. It was very famous attack that's happened 2 years ago in a really in deep details. But again, this is what supply chain is all about. Okay, so let's look at supply chain problems that's happened during 2018, when the new famous WannaCry attacks happened. Okay, and see one attacks can really disrupt the whole world. Okay, so this is another supply chain attack, but this is a real attack. This is where the physical world and the IT world, they come together, and it really disrupt the whole world. Okay, so here the supply chain that's happened in Maersk incident. So Maersk, in a very easy way, Maersk is a shipping company that they really have this big ships, or they call it the ferries that can really take one of these containers and take it from one place to another place. So this is really their main job. And they are so huge, they are really around 20% of the whole world is really relying on Maersk to deliver stuff, okay? How many of these ferries they have? They have around 800. So they are really everywhere in the world. They are very famous in the US, very famous in Spain, very famous in China, okay? Because China now is a manufacturer of the whole world. They call it Al-Masna Al-Alami. Okay, everything that you wanted to really manufacture, you go to China. And China would bring the devices and components from everywhere in the world, and they will start to make it in China. Okay, so this is basically the Maersk as a company. So if we jump a little bit here, so this is basically how big this company is. They are really taking over around 20% of the entire world shipping capacity. So that's a company who is huge, okay? So in 2018, they've been hit with a WannaCry attack. We talked about WannaCry attack when we talked about vulnerabilities and exploits and payload. And we explained what is the difference between all of them. You guys remember? Okay, so the ransom attack, in a very easy way, it exploited a specific Windows vulnerability, which is SMB, entire, it's called Eternal Blue attacks, okay, and it take advantage, and it allows the attacker to encrypt the hard drive. Okay, so this is the WannaCry. So it hit this company, okay, and they have offices in around 170 places all over the world. And look at how many damage it happened, okay? So they had 4,000 servers infected with WannaCry, okay, or طبعا variation of WannaCry, okay, and 45,000 PC being taken down, and 2,500 application over a 10-day period, okay? So application for what? Application for companies, they are not getting their shipment. Why? Because you have your entire machines and entire servers down. That's what we mean. Okay, what we mean by this, guys, is you have a shipment that is need to really go to a certain place. You don't even have the system to tell you where it should go, okay? When it landed somewhere, okay, you don't have the system to tell which truck are coming. Yes, exactly. We are talking about the logistic. We don't even have the system to tell you which truck should which containers. Okay, so you have mercy shipment are arriving this port, and it will be really landed in this port, and you don't really have the system to tell you which truck will take which containers, and you cannot really function. Okay, and these ports are really terminals everywhere in the world. Okay, so they've been experience a really massive disruption. Okay, and the company who is really waiting for this shipment to arrive, they are waiting. Okay, and these guys, their system down or already encrypted. Okay, so what to do right now? Okay, because you have your own because remember, let's say this is China. Okay, they manufacture a laptop. This laptop in the ferry, and this is the shipment company. This is where the supply chain is all about. So you have the shipment company. This shipment company is capable to really deliver stuff, but they don't have the system to tell them where to deliver. Okay, and which trucks will really load which components. So the end customer or the distributed in this company are waiting. Okay, the fault is not from the main source. The fault not from the distributor here. Okay? The fault from the shipment company. So this is why the supply chain attacks is really huge. Okay, so one virus disrupted all these kind of shipments, and it cost the company a lot of money. Okay, because there is a lot of people they are really saying that their shipment has been delayed, and the cause of this delay is basically Maersk, and Maersk, they have some agreement to deliver it within certain days. After these certain days, they have to pay some sort of fine to the client. Okay, guys, this is how big one of these ships looks like, and this is how many containers they look like. Imagine they are just sitting here in the port. They cannot really go anywhere because they don't know where is the destination. They don't have manual systems. Okay, and even if it reach here and offload all these containers to the port, okay, or to this area, okay, there is no trucks, no which containers they will take, because the system that you generate the reports are not also working. So basically, it was a big mess. And there is another really pictures I didn't include it, but this picture was like really a huge row of big cars are standing by one of these ports, are waiting for Maersk to tell them what happened and how they can load all these containers. Okay, so this is another thing to know. So one attacks have disrupted. Okay, and the WannaCry attack, guys, okay, didn't really take only one the Maersk only as a shipment company. They also really affected FedEx. They also did really affected Saint-Gobain, Mondelez. This is like I think you guys seen it. This is like a chocolate company. Okay, and Reckitt and Beckinsale. This is also like a big company in the UK. Okay, all of them, they have already been affected by the supply chain issues, and the cost of this WannaCry attacks cost them around $10 billion. We late and we have fines, and it disrupted the whole supply chain. Okay, so even why this is happening? Because again, remember why we are worried about cyber attacks, because we are relying in technology in unprecedented way. Okay, so we do every single thing right now since morning until we go down at nights on our computers. Okay, big companies, they're relying on servers, they're relying on hardware and software to operate. There is a physical part, which is basically the chips. But these chips can operate only if you have an IT system that supports them. Okay, so we're relying on IT. And now if the IT is down or maybe encrypted by a ransomware that is spread everywhere, and everywhere means in 170 country. So you can imagine that this MRSIC network was really connected. Yani they have branches all over the world, and they are all connected. So one branch is being infected, and it's really distributed to to the other 170 office all over the world. So we have disruption in the supply chain, but this is not really only the disruption I wanted to tell you guys about. There is also disruption in the supply chain when it comes to the security itself of the component. So I just give you an example of the ransomware and how can it really disrupt the whole world when it comes to shipment. Okay, but again, this is a quick introduction, and then this is what we mean by supply chain: the set of three or more entities, organization, or individual directly involved in the upstream and downstream flow of product, service, finance, and or information from a source to a customers. Okay, so what he's saying here, we have three or more. So this is the limit. You have three or more organization. They are involved in the upstream and downstream flow of the product. Okay, so we have a shipment company, we have a manufacturer company, we have a raw materials company. Okay, and we all connected in the same row, and we need each other. So this is what we call supply chain. Okay, so this is the definition. Okay, and they are really producing products. And the guys, if you really also in the Saudi Arabia, you are relying in supply chain in a big time, because you know you have rigs, and this rigs is gonna be exporting oil, and this exported oil will be going to you know, main station to store this oil as a crude oil. And then you have another manufacturer that's have another facility to refine this oil. Okay, and once you refine the oil, you will take certain product, and then you have a shipment company that will ship this oil to somewhere in the world, or maybe ship this oil to your end customer here, basically like maybe a gas station where you go and really fill your car with gas. So this is also a supply chain. So oil and gas also a big supply chain. And imagine if one of these facilities is being hit by attack or cyber attack, what will happen? You will have you will cripple the whole entire supply chain, and you can cripple the entire economy in your case. So this is really how dangerous supply chain attacks as well. Okay, we have already talked about SolarWinds attacks, and I explained how SolarWinds attacks can really happen in the US, and it caused a lot of infiltration for so many companies in the US. Okay, so this is the supply chain. Okay, what is the issue with supply chain? Okay, we understand what is supply chain. What is the issue? Again, the issue is what we have issue right now with is we relying in technology. These companies are really relying on technology. So relying on technology, whether hardware or software, or maybe even middleware, if you have a disruption in one of these software or one of these hardware or one of these cyber attacks, you will lead to a disruption of the entire supply chain. So that is why it's saying here, the world is relying more and more in advanced hardware and software. This is what we call it the ICT. So this ICT is the information communication and technology. Okay, and this is include our server, our computers, And again, also the SCADA system I have already told you guys about, which is really managing the factories and the big like, for example, the water treatment facility and power grids and all this stuff. So we have IT system that really manage all this stuff. Okay, ICT products built on hardware contain hundred or thousand of physical components. Okay, and these physical components are coming from different manufacturers. Okay, also the physical component and software that drive ICT products are typically sourced from a variety of sources. We have already mentioned this, and we now living in the era, especially after the World War II, we're living in something called globalization. And globalization means we are really getting our products from everywhere in the world. Okay, before this time was every country was really building their own stuff, but after 1944, or 1945 specifically, they really met somewhere in UK. I'm not quite sure about the place. They sat together and they said, okay, now we will allow free trade. We have a world of a free order, okay, and everyone can trade for free. And this is where the globalization being born. Okay, if you really wanted to understand where is this globalization really started from, you will find it after the 1945. And basically, this was a US and UK and European country was trying to really convince everyone that we will have a free trade and you can sell whatever you want in our country and we can sell whatever we want in your country. But basically, we are not producing anything. So basically, they are selling everything to our country. So this is what kind of free trade we have right now. Okay, I will not talk about this specific point because this is a little bit political. So the question here we have, after we are really importing all this stuff from everywhere, the question is, are the physical components and the software we are getting are really secured or no? Okay, why I should ask this question? Again, because I'm gonna rely on these software and hardware in my business. Okay, and I have to keep in my mind when I get a motherboard like the one I see here. Okay, this motherboard, okay, maybe, and the RAM and the CPU, maybe it has been created in 4 or 5 different countries. Okay, and how can I ensure that all these components here are secure? Okay, or maybe even the software that I'm using right now has been built in 3 other countries and from two or three different developers, and they're using different libraries and different stuff from even different developers. How can I really secure the components of all these different hardware and software? So this is another question you really need to keep in mind. So here is the 2 questions that we really need to answer here in the supply chain risk. Have the products been designed and tested to ensure confidentiality, integrity, and availability? Means that when you, as an end customer, okay, get a piece of software, okay, or a piece of hardware that you're gonna really use in your manufacture, in your maybe in your government, or maybe in your facility, or in your organization or corporate environment. Okay, have we really tested for security? Okay, so have any one of you guys, when he gets his computer, he said, let me test how secure the hardware and the software are or no? Okay, because if we don't test it, that's mean if one of these components are not secure, okay, that's mean we are also not secure. Okay, exactly. So that's why supply chain is a new topic that we are really discovering today. Okay, and then especially guys, if you're gonna take these components, okay, and you're gonna implement it or you're gonna install it in one of the very important facility in the country. Okay, so if you have a computer and this computer will be installed in the government office, or maybe you create this component and install it in one of your military bases. Okay, so if this component is not secure, that's mean it will open the door for attacks. You can tell me, oh, this is not really the case. Okay, I have already shared with you a case before when I was explaining the SCADA. Okay, SCADA. There is one certain attacks that happen in SCADA called the Siberian gas line, which is basically Siberia is part of Russia. It's a huge part of Russia, but it's all covered with snow most of the year. This is one of the area in the world which is the temperature can go to -50 or -60 degrees. Okay, so this is like really not an area that you can live at, but they have a huge gas facility there. Gas, basically gas mean natural gas طبيعي. Okay, and the Russian wanted really to get a software that can operate the entire gas line. Okay, they didn't have the software, okay, that can operate this gas line. So what happened is they said only Canada, they are operating big gas lines, and we really wanted to really get the software that managed this gas line. So they sent a spy to really, this is back in, I'm telling you guys, this is back in 80s and 90s. So they sent a spy to steal the idea or the software itself, okay? And the spy managed to work in one of these Canadian company, but then the Canadian figured out about this spy, and then they contacted the US, okay? So they contacted the US and they said, okay, we have a Russian spy, and he's trying to get his hand on the gas station software, okay? So the Americans, they said, okay. So they created a software which is a malicious software, okay? It's similar to this original software, but they added certain part of this software to be malicious, and I will tell you what happened. And they gave this software to the Canadian, and the Canadian, they left this software exposed for the spy, and the spy copied the software back to Russia, and he gave it to his government. So he's a hero. He managed to steal the soft line in Siberia. Okay, so this was the case. Okay, so again, they had the software installed, and they operating now the gas line. Okay, they operated this gas line for few years, for a few months, and then all of a sudden, this gas line explode in a really the biggest explode happened in the world after Hiroshima. So this was the entire gas line exploding because of this software, because this is of malicious software. So everyone in Europe was freaking out because they saw that Russia are trying exactly. They saw the Russia. They are trying new nuclear bomb or nuclear attack. But actually what happened is the software was also adding more pressure on the line, and the line reached to the maximum, and then boom, it's exploded. So I don't know, it was like maybe 4 tons explosion or something like this. This is like was really huge fuss at that time, because you have a huge gas line exploding in Siberia and creating so much power that the whole Europe was thinking that at that time, because Europe was not aware about what happened in Canada between US and the Canadian government. So Europe was really worried about the new nuclear. They thought that's nuclear, but then then American called the European and they said, okay, no, don't worry. This was basically the gas line in Siberia exploded. And then a few years later, because America does have this thing that they called the unclassified documents. So after 25 years of this incident, and especially after the Soviet Union collapse in maybe 1981 or 1982, okay, they already exposed this 1991, something like that. Okay, they exposed this operation, and this operation is very well known. It's called the Siberian gas line. So it's interesting. It's interesting. Why? Because I got the software which was really manipulated or not secure, and I implemented somewhere, and it caused a disaster basically. Okay, so the question that you really need to ask yourself, especially if you work in a very high sensitive area, how secure, okay, is my software? How really secure is the hardware? Okay, that I'm getting. So you're not trying to just secure, guys, the application, the operating system, the network, the stuff that we really look at. And the supply chain attacks, we look a little bit deeper and farther than this, which is basically we're looking at, guys, at where is this hardware coming from? Okay, have we tested this hardware from security perspective? Okay, how can I ensure the software that I'm getting from Microsoft or from any other company, okay, is really secure? Okay, so this is a question of the supply chain attacks, and this is really become right now something really big. And I'll explain why it's becoming big in 1 second. I will explain you another attack that's happened in the West, which is blowed everyone's mind. Okay, so if ICT products contain component and software that are sourced from multiple and diverse suppliers, how can we really sure they are all secure? Okay, so we need to also to make sure that the motherboard I have right now, okay, all these components in this motherboard are secure. Otherwise, I'm opening the door for an attack. So, okay, this is something you really need to keep in mind. Okay, so what I have in here, guys, this is kind of diagram. I talked already enough about hardware. So we keep extending the hardware security in like 5-10 minutes as well. Okay, but here also this is a quick diagram for your maybe your company. This is your corporate environment over here. Okay, and then you needed a software. What is this software? Maybe to do an HR stuff, or maybe finance stuff. Okay, or maybe you need to a software for marketing. So you really need a software. Okay, and this software is not available. So you'll go to a primer contractor, and the primer contractor is basically a distributor. Okay, if you guys know how the things works in IT, okay, the big company like Dell, okay, and maybe Microsoft, or maybe Apple, they don't really sell to the end customer right away. Okay, they will sell their stuff to something called distributor. Okay, so in Saudi Arabia, you'll find a distributor for Apple. I don't know, maybe you have Axiom, or you have a company. I don't know what is the name of the company, but maybe, and or maybe even Etisalat or the Telecom company will be the distributor. So if you wanted to buy an iPhone, you can buy it either from Amazon as a distributor, or you can buy it from your STC or whatever. Okay, so they have a distributor. So and then you as an end customer, okay, this is the end customer, will go and ask the distributor for the software. Okay, if they have the software, that's okay. Then they will really give you the software of Microsoft. That's no problem. Okay, but if they don't have the software, what they will do? And this is part of the supply chain over here, and you can see. So if they have the capability to develop in-house, that's nice. So if the distributor have someone in-house, means within his company can really develop the software you as a client ask it for, that's nice. Otherwise, they will go and do what? Offshore. Offshore mean they will go to India, or to go to another country that they are really well known for development. Okay, and they will ask them to develop this software. So we have foreign location, and we have foreign developer. They are developing to do this, and then you will be sent it back to the distributor, and the distributor will be send it back to you. Okay, if you are if the distributor, for example, in the US, he will use US developer, but this is not the case, because the US developer is more expensive, so they usually go for the offshore. Okay, so we can see over here, guys, this in this diagram, there is some sort of supply chain. Okay, and we really need to understand how these guys over here, they look at the security. Okay, we need to understand their mentality. Okay, we need to understand how they build really the software, what kind of component they use in this software, what kind of library they do in the software, and what kind of test they did in this software. So we really need to understand the whole cycle here in order to, if we get the software here, we make sure that's secure, because I'm gonna deploy it in every single computer in my organization. So I need a secure software. Okay. So this is will take us. طبعا there is this is a very simple way, guys, to look at the software security. Okay, but the software security is going through stages as well. So the stages, if ICT product contain component and software that are sourced from multiple and diverse suppliers, like in our case right here. So it came from the foreign support, from the foreign developer. It came to us as a distributor. The distributor then give it back to the original client. Okay, we really need to understand how secure it is. Where can the supply chain attacks occurs? Okay, if that's maybe these guys have already implemented backdoor in their software. Okay, or maybe the distributor added something here that cause vulnerability here. Okay, and then end of the day you will be responsible. Why? Because you're gonna add your data and your very important customer information in this software. Okay, so this is also something you really need to understand. So and that will put in our organization some sort of responsibilities to really take care of the softwares. Okay, so how can we really secure this? How can we really make sure that we are involved in every single phase of the supply chain? Okay, so we really need to implement the supply chain from the early beginning. Okay, so if I'm gonna talk about the software at least right now, okay, because hardware is even harder to control. Okay, so let's look at the supply chain. Each software you require as a company, you will have a list of requirements. This is part of the SDLC. If you guys know what is the SDLC, which is basically the development life cycle for a software. Okay, and it starts always with a requirement. We really need to specify what our security requirements from day one. Otherwise, you will get a crap when it comes to security. So here, the first thing that you really need, requirement, what is the hardware or software supposed to do? Okay, so this is basically the requirement phase. Okay, so you're not only putting the security here in the early beginning, because right after you build the software, it's gonna be hard to really add more feature as a security. So the requirement here phase is very important in the supply chain. Also, in the design phase, when you design component or software based on the requirement, you need to also to have a secure by design, secure by design. So what we mean by secure by design, we need to implement the confidentiality and integrity for the entire design as well for the software. Okay, and the same thing in the hardware, but I'm just giving you the example of the software. Okay, we really need also to really implement another, the next phase after this is the implementation. So let me just try to move to this phase, which is developing or the really manufacturing. Development means I'm developing the software now. I took the requirement, I took the design. Okay, the design, how many tiers I have web application or I have Windows application. It's running on a database. This database is going to be my SQL or SQL database. This is all the design. Okay, and you need to add all the feature of the security here in the design as well. Okay, once you have the requirement and design, you move to the basically implementation and development. And then in development, you really need to implement something called secure coding. And secure coding practice, maybe you know it or no. That means I'm gonna use a proper library. I'm gonna use a proper functions. I'm gonna use proper I would say code that is really secure. Okay, so this is really also need to be implemented, and that's why in so many occasions that you have here in the development guys, you find something that we talked about it before. Is called the static analysis. Static analysis, guys, means that I have a software that it will scan the code that has been already written, and it will find any malicious function or any malicious libraries or any malicious code, and then it will highlight these bugs to the developer. So you can really fix this bugs in the early beginning of development. Again, why? Because the more further you go in this supply chain, the harder for you really to really go back and fix it. Okay, so that's why we have a static analysis here, and there is so many application, and we even mentioned one time that the WAF itself, sometimes it comes with a component to scan your code before you publish the code, especially in the web application. And then basically it looks for the injection attacks and all the stuff. So this is a static analysis, okay? Once you have the code compiled and running, so you start to do the testing. And this is where you would start to do something called dynamic testing. And the dynamic testing, basically where we have our tools like the vulnerability scanners, and the one that we have covered 2 days ago. So the vulnerability scanners can do something called dynamic testing, and the dynamic testing only happens when you have the code running and compiled, okay? So this is very important as well. So this is another phase that you look at. So you basically, you're looking at security in each and every single phase, from development all the way, guys, to testing. Once you test the software, طبعا there's so many type of testing here, guys. There's something called unit testing and integrity testings. There's so many ways, but I'm just talking about security just for the perspective of my the lecture today. So once you have the testing, you start to distribute. This is where the distributor get in place, and they start to give you this product and ask you to install and to execute this product. So this is where the product, to get the product to the customer, includes software updates, and that is very important as well. Why it's very important, guys? Because once you have a system, even when you are put requirements, security in the mind, put design security in mind, tested the static analysis, tested the dynamic analysis, you still can find after time some vulnerabilities. Okay, so even Microsoft, they do have the same cycle, but then later on, after the Windows already installed in someone, they said, okay, we find another vulnerability here. You really need this hot fix. So there is after distribution, there is a very important aspect of software updates, okay, or maybe security updates. So this is even in distribution, okay. Once you are distributed and executed, you start to use this, okay, and maintain it. Also, the maintenance means I have to look at the security aspect also after deploying it, okay. So did we have already figured any new vulnerabilities in the software? Okay, where is the update for this software? So this is what allow you to really use the software, and you feel you are confident that you are using a software without really bugs or security backdoors. Okay, customer are using the product for intended purpose, and the maintenance means basically the updates and how to really secure the systems once it's deployed. And that will take us to what we have already covered before in this area, which is we call it hardening the system. And hardening means make your system is hard by allowing the service attack for someone to attack your system. So you really need to, in this area, guys, to implement also hardening and to get the latest update, which is we call it batch management, and we have already covered this in one place. And once you're done with the systems, خلاص, the system is already finished. Maybe after 2-3 years, you don't need the system anymore, or maybe you are really gonna dispose of the system and get a new system instead. So even in disposal, guys, you need to really be careful for what kind of data exists in this system. So you really need to get the disposal in a very secure way. Okay, so you needed to destruct the data, or you need to make sure that you broken the hard drive, or maybe you are really overwrite the data maybe more than 20 times in order to dispose it, and no one will be able to recover this data, or even encrypt the data and then delete the keys, so no one will be able to brute force and then get the data back. Okay, guys, so this is kind of things that you really need to do every time you buy a software or a hardware. So you really need to do a whole requirement. Okay, I'm just gonna give you something from my perspective. So for example, the 6.2 443. This is a standard, okay, for SCADA system. Okay, guys, this is a standard for SCADA system. And the standard basically is standard about security. Okay, and it's saying, okay, if you are gonna be a manufacturer, you are gonna be a vendor who's gonna create PLCs and sensors, okay, you really need to take care of your equipment when it comes to security, especially when you build your security. Sorry, you build your PLCs and sensors and motors and engines. Okay, so we really need to put this in mind. Okay, and the distributor, okay, the one in between. This is the distributor, guys. Okay, and here is the client. The client need to be very smart. Okay, when they order their equipment or SCADA system, when they are ordering it from the distributor, they need to give the distributor what is their security requirement and what is their design requirement. Okay, when it comes to security. طبعا there is other requirement how these things will operate and stuff. This is not the point I'm talking about. I'm talking about the security. So now, if you are aware that the hardware can be attacked, especially we have seen Stuxnet and Aramco has been attacked so many times. So I really need to get my SCADA system and the computers that run SCADA is really insecure. Okay, how can I close this gap? So you need to pass your requirement to the distributor, and the distributor will pass your requirement to the vendor, and vendor, when he started to manufacture your PLCs and motor and engine and pumps and all the stuff, he really need to take this requirement on the manufacturing phase, and then when you get the stuff back here, once he finish manufacturing, he will give to the distributor give it to you. You should run the test to make sure that all the requirements, security requirement for your environment is really there. Okay, so just one thing also to keep in mind. Okay, what is the security requirement? As a client, okay, I don't really know a lot about security, okay, because I'm just a poor guy who's running maybe a facility for maybe you know, milk or dairy products, or maybe something very simple. Okay, they said, don't worry, we will give you a document here. Okay, it will give you something called security level, and the security level are divided to 5 levels. Okay, and these 5 levels, it's telling you if you are trying to protect your facility from normal, I would say, a script kiddie, like a really really advanced attacks, you really need to do this and this and this. So you take this requirement and pass it to your vendor. If you really wanted to protect your environment from a nation state APT, guys, you really need to get all this security requirement and pass it to here. Okay, guys, so this is, we can see that so many standards out there, they are trying to close the gap of the supply chain. Why? Because it's huge. Okay, if you don't believe it's huge, I'll give you one single I'm sorry, that's what time is it now? Okay, can we continue 15 minutes more and then we can go for break? Hello?
Yes, yes, it's nice. Okay.
Are you guys still alive? I know it's Thursday, guys, and I know
Yes,
that
with
you are.
Mr. Shadi. Keep going.
Okay.
No problem.
Okay, so let's go and see one of the attacks that happened in hardware. They called this attack, guys, the big hack. Okay, and why it was important? Because Bloomberg is one of the biggest news outlet in the US when it comes to finance, is the one that announced that after 1.5 years of investigation, we find out about this attacks. Okay, and this attacks, basically the US was accusing. It's not accusing this time. It's really saying, so test steps is also by client to batch the systems. So that the testing step, okay, is also by the client to batch the system. Yes, so the client, guys, will contact the distributor. We say, okay, we need to test this system to see if it's really satisfying our security requirement that we're early beginning we have already set for the vendor. Okay, so you really need to go back and test, because if you don't test, how can you really ensure the security? Okay, I can tell you I need a system, a Superman systems. It do all the authentication, multi-factor authentication. It do all this, it's gonna stop all the RDP, the remote desktop connection and everything. But how can I assure the system are doing this? Is when I get the system on hand, okay, I really need to test all the security feature. If one of the security features is there, that means this is a violation in the contract, and you really need to go back to your manufacturer and saying this was in the early requirement. So that's why, in order to tackle the, I would say, this risk of supply chain, you really need to have an open channel between the vendor and between the clients, and the clients really need to really ask for the best breed of security measurement to ensure the hardware and the software is developed with security in mind. Okay, and again, guys, if you don't see any attacks, I already explained the Siberian gas line attacks. You can go back and check it online. It was big in the news, so you will find many articles about it. Here, it's another one that has really made the news in 2019 and make everyone was really, whoa, what's happening here? Okay, so this is the big hack, how the Chinese used a tiny ship to infiltrate US big companies. So they infiltrated basically Amazon, Apple's, and then a lot of also, companies in the US. How they did this? Okay, and this is back to, this is an extensive interview with the government and corporate sources. Okay, so Bloomberg, they have done like a research, not only an article, but this is the article called The Big Hack. So if you wanted to read the whole article, you can go. So let's go and see what happened in the Big Hack. Okay, so they said, okay, they used to bring a motherboard from the US, and this is, let's say, this is how the motherboard looks like. Okay, so this is the entire motherboard, and this motherboard are manufactured in China. Okay, and there was certain tiny chip in this motherboard. How big is this chip? Is as it's showing over here. This is how big is the chip. If you put this chip inside the motherboard, this is white dot over here that we cannot see. Not all this one. There's a white dot here in a small dot, in the middle of this circle. Is how big is this hardware? Okay. So, and they mentioned that this specific, I would say coupler, I will explain what is coupler in 1 second, was able to manipulate the, the operating system, and opened a back door for Chinese to really steal data from big US companies. Why? Because this motherboard was part of something called server, and these servers are really being sold to a lot of manufacturers in the US, like Amazon and also Apple's. And again, Amazon, do you have AWS? And means this server and already went to the client eventually. So it didn't really infiltrate Amazon. They infiltrated Amazon and everyone that used to use AWS as well. The big hack using the tiniest chip. Exactly, Elam. Yeah, I agree. So also here, this is the motherboard, guys. Okay, this is the motherboard that's is being accused of this hack, and you can see over here, this is the place of the tiny chip that they are really claiming. So for looking at all this motherboard, you can see it's just occupying a very small area in the motherboard. Okay, guys. So this is another thing to keep in mind. Okay. So this is basically the supply chain attack according to Bloomberg. This is the whole story. It's saying that the Chinese military, okay, designed and manufactured microchip as small as pencil tip. Okay, they are really developed a small a chip. And how big is this chip? You can see in here again. Okay, so this was the Chinese military. Okay, some of the chip were built to look like a single conditioning couplers. Okay, this is like something that takes signals and really managed to sharpen the signals okay? And they integrated memory networking capability. These chips, these small chips include memory, so it can save data, and it also can allow to the chip to get network capability. And it's also getting from the motherboard itself a sufficient processing power for an attack. So this chip basically a small computer, okay? Because you have power, you have processors, you have memory, and you have power to operate in the network level. So this is like, I would say, a small mini computer, okay? The microchip was inserted in a Chinese factory that is supplied Super Micro. This is a company in the China called Super Micro, one of the world's biggest seller for a server motherboard. Okay, so you are getting again, just to explain this, guys, so everyone can understand, can see this diagram. So you have a company here in China, okay, and this company is called Super Micro, okay. The Super Micro is really good in just creating the motherboard of a server. So the server, if you guys know, this server, you have the motherboard and you have other components installed in the motherboard. You can have a CPU, you can have a memory, okay. You can have also certain security components, okay, installed. So this is all coming from different manufacturers, okay. But the main manufacturer for the motherboard was only one company, okay. And then the server, there is a company in between, will buy this motherboard, will put it here, okay, and they will add the CPU and the memory and all this other stuff, maybe, and then they send it back to the US. Okay, and this is the US. We're taking the whole server and we install this server in our data center, okay, or Amazon data center. So this is how they attack. And you can, as you can see from the last two slides, there was a very small, tiny chip over here. This is created by the, they said, I'm not quite sure who created this chip. As they said here, it's linked to the Chinese military, okay? And they added this chip here. The chip was added to a whole server. The server has been sent back to the US. So this is, as you can see, this is a supply chain attacks. Why does a supply chain? Because the company who created the motherboard is different than the company who created the memory, different than the company created the CPU, okay? And all of them are eventually went to the client over here. Okay, so the client should be able to really test all this stuff. Okay, test the whole processing. Okay, so here the compromised motherboard were built into the server assembled by the Super Micro. The sabotage servers made their way inside the data center operated by dozens of the company, including Apple's, including Amazon, including even military bases. Whenever the server was installed and switched on, okay, the microchip altered the operating system core, so it could accept modification. So now the Microsoft, whatever the operating system, that's really exactly, it's very difficult to detect these kind of things. Okay, so again, the microchip or this tiny chip managed to really alter the operating system so it could accept modification. What kind of modification? Network connections. Okay, the chip could also contact computer controlled by the attacker in search for further instruction and code. So this chip was also capable of connecting back to a command and control center to accept more data from the attacker. So this is another thing that you really need to know about this chip. Okay, the chip essentially created a backdoor to the server, allowing million actors on يعني بيسموهم evil actors to connect to it and then alter or capture information. So basically, this was a backdoor, okay, and this backdoor will connect back to the Chinese military or whoever was really behind this attack and allows them to really manipulate or steal information from the computers. Many actors didn't have to hack into the system. They were provided a built-in door in the system. So basically, you are giving a system which is has a built-in backdoor. Once you switch it on the system will start to connect to you, okay, and then you start to get data out of these systems, okay. And this is a hardware supply chain. So what I was trying to say, guys, here, that's in software, it's easy to really monitor every single stage and try to minimize the cybersecurity risk, because you can get in the requirement, you can get in the design phase, you can get in the testing phase, you can, even when you get the system, you can implement your own dynamic testing, and you can really find vulnerabilities and ask them to modify this from their end or install a patch for it, okay? But this kind of attacks, the hardware attacks, is very difficult to attack, very difficult. Why, guys, is very difficult? Because you have a motherboard that has a lot of chips from different companies. So some of these chips are coming from China, some of them are coming from Taiwan, some of these chips are coming from Intel. So you really need to make sure all these components are secure in order to really have this hardware installed in your system. You understand why supply chain is really big right now? And so really providing supply chain risk assessment is even a hard job, but we try as much as we can to really reduce the risk of these supply chains, okay? And especially if you have been targeted by something like this, okay, really it takes a lot of time to really figure out what happened. If you really wanted to read the whole report is published by Bloomberg, so you can really get more details about how they figure out these attacks and how they really stopped to deal with this company anymore, and they stopped all the manufacturing of motherboards. And that's why, guys, you can tell why Trump really got really crazy about Huawei. Sometimes they call it Huawei, and the technology of 5G. And he went everywhere. He even went after the daughter of the CEO to arrest her in China, sorry, in Canada. Why he was going crazy? Because basically you now are buying the Chinese 5G technology and implement it everywhere in the US. And that was really, I think, was really crazy for him. Because if the Chinese was managed with a small, tiny chip to really hack into all the servers in this corporate, imagine if they own the whole 5G networks with all the equipment there, what they can do. And that's exactly my perception about the technology. Whoever creates the technology, he can easily spy and really cause damage. So if our network, for example, just give you an example. If your network in Saudi Arabia, okay, you have a mobile network coming from Ericsson, okay, or from Siemens, or from Nokia. I don't know who is building your towers right now, or from Huawei, okay. So Huawei, if they really wanted to really infiltrate all your data, this is going to be easy because the technology itself is coming from them, okay? They know everything. They know the hardware. They know the software, okay? And they will be able to easily find the back door to infiltrate this data. And that's why you really should be very careful in your life when you use any technology, okay? Just to give you a story before we go for a break, okay? So the story is about Apple phones, okay? So Apple phones emerged in 2003, 2004, or 2005, around this time, okay? So this is where we had this iPhone 4 or 3S or whatever, okay? When they created this iPhone, okay, there is one guy called John McAfee, okay, they told everyone, these phones are really a way to spy on people, okay? And this company who's called Apple, okay, they will be able to really infiltrate people privacy. We'll talk about privacy, inshallah, next week, if we have, inshallah, time, okay? So people started to laugh at him. They said that this is the best invention ever. How can you say something really bad about them like this? And then he said, okay. So he brought all this reporter from different news outlets. He brought them in a one single place, okay, and he asked them to really connect to the Wi-Fi, okay, and he managed to really hack all their phones, okay, and this is in 2004, okay, and they said, look, if I am not the manufacturer, okay, and now I can hack all your phones, get all the SMSs, okay, got all your conversations, okay, imagine what power Apple's has in your phones, okay, so this was his proof of concept that these phones are really gonna invade people privacy. Again, you can see there's also Facebook are spying on people. There's so many things that you should be aware of, okay, as an end customers, okay. And also that's why in military bases, I can understand 100% why they are not allowing any phones inside, because basically specifically in the, okay, this is nothing. Having your IP address is nothing. They can locate you by this IP address. This is not just the IP address. You shouldn't be worried about the IP address. The IP address, eventually, you are getting it from the service provider. So it's okay. Anyone can have the IP address, no problem. But I'm talking about really, really bad stuff happening, okay? Spying in people really private life, okay? If you guys wanted really to see a movie that's gonna really dazzle you, especially in the early beginning, I just wanted you guys to focus about in the movie in the first beginning, the Shadow, not Shadow, Snowden. Sorry, Shadow is like something else. Snowden, a Snowden attack, Snowden movie. They made a movie about him and how he escaped to Hong Kong and why he really was troubled. Snowden. I think it was a movie.
Yes, right. I see it before.
Yeah, it is crazy. But I wanted you guys to really focus in how they used to invade Afghanistan, okay, and really watching inappropriate stuff about Afghani people, and they managed to really hack to computers. They turn camera on, so you are sitting in your computer and your camera and your mic is on, while the camera is not giving you any lights, and really they are watching stuff. It's crazy, but just yes, exactly. Snowden movie. I don't know. I don't remember what is the name of the movies, to be honest. Yes, this one, or yeah, this one. Edward Snowden. Okay, so this one. Which one? And then yeah, I think this one. This one. Yeah, it was in 2016. Okay, so this guy is a movie that I'm telling you guys. I wanted you guys to really watch this movie and see how we reach to really different level of spying, okay, when it comes to spy to people. And again, one of the reason why, because basically you own the technology. And that's why I think it will not be solved until we start to create and build our technology from scratch. And this is also something that I noticed over the years. They will not allow you to create your own technology. They don't want to even to give you the basic stuff to build your own technology, because they wanted always have all the time infiltrating you. I'm not gonna say who wanted to be benefit of this is of things, but again, I worked in an organization before. It's a research organization in UAE, and the whole idea behind this organization was to build basically chips, like microchips, okay? And they have an association with South Korea and you name it, Japan, all these countries, and none of these countries, including Taban, US and UK, wanted UAE or any other countries in the Middle East to have the technology to build microchips. And eventually this organization has turned it to be an educational organization because they really failed they failed the whole purpose of the organization to build the microchip. Okay, so the idea from Sheikh Zayed Allah yarhamu was to, okay, we need to build our own technology. We need to know how to build a secure microchip, or even a microchip that it will allow us to do our day-to-day jobs. Okay, but again, no one have already wanted to really give you this technology. Why? Because they wanted always to have the upper hand. Okay, so this is the conclusion of here. If I tell you what I know about these topics, you will be really scared. But again, this is enough for this area. Are we gonna talk about HSM when we come back from the, inshallah, the break? So you guys enjoy the break. I'm sorry we took sometimes in the morning to talk about this one, but this is an important topic. So we'll talk about 15 minutes break, guys. So 15 minutes break, and we come back around 10:50, inshallah. Okay, enjoy your tea break, and I'm sorry that we took a little bit more. And I will save it in a one centralized server over here. So this server will be able, okay, I'll just give you an example to understand what's happening. Let's say I have an application here. They are using TLS to communicate with the client, okay? And this is the guy over here is receiving my data. Okay, so my data will be generated here in the application level. And before sending this data to the client, all the encryption will be done in HSM, and then it's going to be sent to the client. Okay, so the application will generate the specific data, and then this data will be sent to the HSM. The HSM will generate the encryptions, or he will create the encryption and send it back to the client. Okay, so I'm offloading the encryption and decryption methodology from the CPU and the memory and the hard drive and even the application, and all the application of encrypting and decrypting. So if this guys, for example, will reply back encrypted TLS message, this message will come here, it will go to the HSM, will be decrypted, and then it will reach to the application level. So this is one of the functionality of the HSM. First, we store the keys over here. Second, any encryption or decryption will be the responsibilities of the HSM as well, okay? And the third one, if we wanted to generate keys, whether a public or private key, we can create it on the HSM. So this is 3 functionality, okay? So if you guys can see, this is basically the 3 functionality. Data is sent to the HSM for encryption or decryption, okay? So this is one functionality, okay? Second, requests are made to generate data encryption keys or to sign keys. Second, okay? All operation happens on the HSM, and the storing the key is also happening on the HSM. So the whole key, they call these guys key management process, okay? What is the key management process? When you are implementing encryption, you need to create keys. You need to maintain these keys. You need to store these keys. And you need to really deploy these keys, and sometimes you really need to get rid of the keys. So the key management process is one of the hardest things that you can do, okay, especially if you're gonna save these keys in your hard drive or something, and someone attack your computer, it will be able to see the keys. So HSM is gonna handle for you the key management process. If you wanted to see how the key management process looks like, guys, because we don't have much time, I will show you to you very quickly. So this key management process is here, okay? So this is the key management process. So the key management is the hardest part of the cryptography, because this is where I can generate the keys, I can save these keys, I can back up these keys, I can reuse these keys, I can get disposal of these keys. And often is Achilles' heels okay, of another of an otherwise secure system. Okay, this Akhil Heels, this is a very mythology coming from Troy movie. That they have this guy who was super strong, okay, but the problem is he has a small area in his is in heels. If someone hit him in this area, he will die. So this is kind of, you know, the weakest point in encryption. Usually, guys, is how to really save and handle the keys. Because if the attackers manage to reach your keys, this is going to be really bad. Okay, so how the key management works, you need to generate the keys, you need to exchange the keys with parties, you need to store the keys, you need to rotate the keys from time to time, okay, and then you need to archive and then destruction of the keys when you don't really need it, guys. So who is going to do this on behalf of our operating system? Now HSM is going to do this. It's going to generate the key, it's going to reuse this key to implement encryption and decryption. All this happening in the HSM server, okay? And then it's going to rotate the keys. And finally, if you wanted to get rid of these keys, we can get rid of these keys. Okay, guys? So this is HSM functionality. Okay, there is some things that you need to really
Excuse
need
me,
about.
Mr. Shadi, it means like a case we studied before, private key and primary key.
Yes,
Like
this is the keys that you started. Because
okay.
very good question, Nasiba. Nasiba is saying this are the keys that we used it before, the public key and the private key. Yes. Okay, we mentioned that public key, I'm giving it to everyone, okay, to really encrypt or encrypt the data and send it to me back. And I will be able to decrypt this data using my private key. Your private key usually are loaded in memory, okay, and loaded and saved somehow in the hard drive. Okay, so but this is our this computers, this servers, we don't have to we have to remember that this is gonna be our web server. Okay, and usually web server is the first place the attacker will try to penetrate or exploit, because this is their ideology about how to have island hopping. So they always really try to focus in your web server and try to really exploit your web server. So if they exploited your web server, they can steal these keys. If they steal these keys, this is going to be a huge problem for you, because they can decrypt all the traffic coming from the client. So this is why I need to really secure and save these keys in a very secure place. So we came up with the HSM. The HSM, as you can see, keys are stored securely inside a secure enclave. Keys never leave an operation are performed in HSM. So when you add the keys here or you generate keys, guys, the keys will never leave this, even in a physical attacks. So if someone takes this take the whole HSM server and trying to really open the hard drive and take all this data, they will not be able to do this. So this is really good secure place to secure the keys for your infrastructure. Okay. Another thing that you really need to know, if someone managed to exploit your Windows machine here, guys, and can have your credential as an admin, now he will be able to extract the keys for the private key, because the admin can do anything. And we mentioned that these keys are part of the memory sometimes or part of the hard drive. So if he got the admin permission, he can really easily do extract these keys. But in here in HSM, okay, we have a separate username and password and authentication methodology to access the HSM. So this is another layer of security. Why? So your username and password for Windows will not be acceptable for HSM. So even if he compromises your username and password, he will not be able to compromise the HSM, because we are using different authentication. So you really need to connect to the server here using different username and password. So even if he exploits your username and password, your keys are going to be secure, because your authentication methodology here is different. Okay, guys? So this is another thing that we have to really look at in HSM. Okay, another thing that you really need to look at in the HSM, guys, is HSM are tamper proof. This is what I was trying to explain to you. Proof and hardened against physical or logical attacks. So these servers, guys, are really, I would say, has a specific operating system, and this specific operating system are really hardened. Hardened mean that I'm closing all the service in this system, so it's not easy to attack. Okay, not like your computer, because your computer, especially your web server, you have port 80 is open, you have port 443 is open, you have another port is also for communication is open. So attacking a server with a large, I would say, attack surface is easier than going after an HESM, because HESM has a smaller attack surface, and it's not even, as I mentioned, if someone even steals the server, okay, and it try to take this data out, guys, in a physical way, it will not work, because they have special material they made the memory of this server with. I will explain how they made it later on. Okay, so even if you try to extract it in a hardware level, it will not work. So this is very good. So from the attack service point of view, it's much better than your web server. Okay, from also attacking it from a hardware level. Okay, if someone steal your server here, he will be easily able to see the data here. Here, it made out of material that is not easy to extract the keys from. Okay, so this is another benefits of these kind of system. Okay, let's move on. Here, guys, even the HES admin that we managed to say that he will have an admin permission to really access the HSM, they have limited privilege. You remember, guys, we have in security something called the principle of least privilege, and the privilege here for the admin, it will allow him to maintain and update the server. So some updates are there, but he will not be allowed to see the keys or to see the encryption and decryption process. So from the admin perspective is good, because you know what? Even if the admin get compromised, he will not be able to affect the servers because he doesn't have access to the keys. So here is saying the rule separation or the least privilege. HS admin can update and maintain, but do not always have full access to the HSM. Okay, so this is also very important. Okay, type, how can we as a web application to communicate with the key? So I have a server, okay, trying to communicate with another server. Okay, in this ways, guys, they do some sort of request and reply. And this request and reply is done by API. I don't know if you guys studied API, you know, especially REST APIs that some of you maybe heard about these APIs in the university, but in a very simple way, API is a way for two machines to exchange data. So I will request data from a machine, and I will get the response from these machines. Okay, so it's saying that if I have a web server and I have the HSM installed, they will speak in an API which is very secure. Okay, and they have used a very secure APIs to communicate. This is also to ensure that the request coming from the web server to your HSM, okay, is very secure, because your data here will be encrypted or decrypted, and then will send back to the web server. So we really need to use a secure API, and that is why it's accessed via tightly controlled industry standard API, and this API is something coming from a well-known organization like Java Cryptography Extension or Microsoft CryptoNG libraries. So the API even that is gonna be used to really send the data and receive data between the HSM and your web server is secure. So this is another thing that we really need to know about the HSM. Another thing that you really need to know about the HSM, that your web server now, we're gonna offload from him a big headache. Why? The encryption used to be done, and the decryption used using your CPUs. Okay, so your CPUs and memory was always being exhausted by doing the encryption and decryption for all these TLS clients that you are ended up visiting your website, right? So right now, all this has been moved from my web server, so my web server just can have to work normally, and all this heavy loading or heavy lifting is gonna be moved to my HSM. So the HSM is gonna offload SSL TLS processing to HSM, which is more secure environment, and it's going to be more efficient for my web server because I'm going to offload this load from my web server. Okay, guys? So far, so good?
Yes, so far.
We can also use the TSM, you mean TBM, well, HSM, full encryption. Okay, yeah. I'm not sure about the TBM is something in your computer, okay? And this is where the TBM guys in your computer, this is where we save also keys and, you know, and also generate keys. And if you decided to encrypt your hard drive and you have your TBM installed and provisioned, this is where your keys will be stored. Yes, TBM. Okay, great.
And
so the
also,
TBM,
API is very commonly used because
yes,
they
in
enable
web application.
to access sensitive software function, and
Yes, I
so
agree.
become primary target for attackers.
Okay, yes, I agree. Also, one of the usual case to use, we can use the HSM guys as a hardware or server. I will show you how it looks like in 1 second. Okay, it can be used for PKI signing certificate. So what I mean here, guys, if you guys remember in PKI infrastructure, we used to say that we have something server over there called the CA, the Certificate Authority. Okay, and the certificate authority in a very simple way, this is if you are a web server and you really wanted a certificate, you're gonna contact the certificate authority. The certificate authority is the entity that will issue for you a certificate. Okay, and the certificate in a very basic thing is a public key and a private key, right? So in this sense, I need a certificate authority to create certificate. But what he's talking about here, guys, sometimes within your organization, you need certificate, okay? You need to create a certificate between your web server and your database to communicate in a secure way. In this case, I don't really need to go to a certificate authority saying I need a public certificate, because this is kind of certificate that you're gonna do internally. So if you are gonna use something internally with encryption and decryption using a certificate, you can ask your HCM to create this certificate and sign the certificate as if it work as a CA in this case. Okay, guys? So this is another functionality of the CA. If you guys wanted to really see how CA looks like in general, sorry, HSM, we have two versions of HSM. We have physical servers you can buy and insert it within your organization. This is HSM, they called it, let me show you guys here. HSM. Okay, so this is gonna be, they have Salas HSM is very famous right now, and there is a course that covers how to use this HSM. It's really very good. It used to be a company called SafeNet, and then Salas bought this company, and now they are selling these HSM servers. And again, this is a very powerful server, and the cost of these servers are crazy, maybe $20,000-$30,000 per one device. Okay, guys. Again, this is a solution. If you don't want this solution, okay, AWS, they have their own, okay, they have their own cloud version of HSM. So you can go to really AWS. So AWS HSM solution. So HSM is not free, by the way. So you can see they have cloud solution. That means you can save all your keys in HSM within the cloud, not a hardware like the one that I showed you guys from basically the one calculate HCM cloud architect cost and signal. Okay, create a content to estimate. So this is basically I was sharing with the guys how to create Cloud HASM. So getting started with this one, you can see that you can really create SHM here. This is in one documents, and you can really create and provision your SSM using these commands. So this is another way to implement HSM. So you either do it on premises, you buy this box, you buy the server and install it, and then connect to it all your web server requests. So this is basically one way. The other way, if you have your instance and you have all your servers in the cloud, it will make sense that you also buy an HSM from the cloud to work with your premises. So this is another way also to look at it. Okay, everyone understand what is HSM in a very brief way?
Yes.
Okay. Also, one thing that we really need to know before we go ahead and look at the HSM in more details is basically is hashing. And hashing, as we mentioned, this is a one-way function to really turn data or to really create a message digest of certain data. So for example, if I have this picture over here, okay, and I wanted the hashing, okay, what I can do is I can say I will use one of the hashing algorithm here, which is MG5. I will give him the original data, and it will create one piece of data here. This is a message digest, which is the hashed function of this hashed digest for this specific picture. Okay. And one way, guys, we using hashing for is our antivirus using a lot of hashing, because what happened is when we find, if you guys remember, when we find a malware in the wild and we started to really wanted to create a signature for it, so we take the hash of this specific malware and we create, we find a malware, create a hash, and then we add this hash to our antivirus or maybe anti malware, and it will be able to recognize this malware and get rid of it in the future. So this is basically how hashing is used. And there is also so many applications right now for hashing. So if you're downloading stuff from online, you can always calculate the file hash and see if you downloaded the right version of the file or no. So there's so unlimited numbers of function of hashing. Okay, so why we need an HSM? Again, cryptography or cryptography encryption in general use secret keys, whether this secret keys is a private key or the symmetric keys. Okay, how can we keep these keys are really secret? Okay, so especially if we have attackers that they are well funded and really knows how to exploit the system and really need to can able to exploit your machine. So I really need to have a mechanism to really keep my secret key secure. So this is the main thing. Okay, again, the hardest part in encryption is not to choose the algorithm that I'm gonna use. Okay, the algorithm are well tested and well known. So we're gonna use RSA encryption, or we're gonna use EES. Okay, we can use 3DES. So these algorithms are really secure. Okay, the problem is that fall in our hands because we're doing the encryption, not the algorithm. There are so many people are testing this algorithm day and night. SHA-1, SHA-256. So this is not our. This is another area of cryptography called crypto analysts. They are doing their job. Don't worry about this thing. What you should be worrying about is the key. The key is going to be stored in your application. It's going to be stored in your web application. It's going to be stored in your database, or going to be stored in even your computer. So you really need to secure these keys. Okay, and securing the keys, we have something called the key management life cycle. It starts from generating the key in the first early beginning, all the way that until we destruct this key at the end. So the whole this keys lifestyle, from generation to use to rotate until with destruction, we need to manage it in a proper way. And that's why we have the HSM, because the HSM can take care of your keys in all the stages of the creation until we have the key. So again, the HSM is a hardware security model. Okay, it's a cryptographic computing hardware, cryptographic hardware, mean it's made only to do the cryptographic. So we use very specialized hardware in order to do the cryptography in a very fast and efficient way. And that's definitely will help us also in the speed and performance when it comes to encryption and decryption. Okay, it can protect the key store or protected key stores, mean that I will have my keys are protected in a very well known environment. Okay, it's well-defined interface protocol. That means that I'm gonna use a well-defined APIs to communicate with my my HSM and response back. It's very hard to compromise. And this is all other names of my HSM. I have personal computer security modules, secure application modules, but the really one that is very common between a lot of the security folks is basically hardware security mode. Okay, the HSM challenges. Okay, HSM store. Okay, protect and manage sensitive cryptographic keys in a centralized high assurance appliance, providing a root of trust for all sensitive cryptographic data transactions. Okay, HSM works seamlessly across your on-premises, private, public, and hybrid and multi-hybrid environment, so you can use it over the cloud. And if you're having a hybrid environment between your cloud and your on-premises, you can still use it. Okay, HSM is the most trusted purpose with market-leading performance through hardware-based security. Okay, so this is all good things about HSM. Okay, so we have also on-premises, the one that I showed you from Thales, this one, the server, and we have also cloud HSM. As you can see, they have Amazon and they have IBM. Okay, guys, what we mean really by, we mentioned this 4 area of really good things about HSM. So let's look at the cryptographic computing hardware. So it's saying that they have something called hardware accelerate cryptography. So I can really do the cryptography operation in accelerated way, which is basically, that means it's gonna save me time and it will increase the performance. So, and it can do the both sides of the cryptography in a very hard way, in a very soft, in a very fast way. And as you guys can remember also that we mentioned that symmetric is usually faster than asymmetric, but this hardware acceleration will work in both kind of technology. Okay, secure random number generation. This is especially when you work in cryptography. Okay, you from time to time you wanted really to create something IV, and the IV is basically a random number that is generated when we do encryption and all the stuff, and it's really can help you to secure random number generators. It can allow you also to understand to do some hashing, and so if you are signing signing data that you are sending to the outside, especially if you're creating a certificate or something. So the hashing there is also included, and the message authentication code is part of also of hashing. That's why I explained hashing in a very efficient and very small, brief way. But the hashing again is to one-way function to create a message digest out of data. So this is also can be done using the cryptographic computing module here. Okay, the protected key stores mean the key stored in a tamper-proof, non-volatile memory. What we mean tamper-proof? You cannot change the environment there. Okay, and it's non-volatile memory means even if we restarted the HSM or we lost the power for HSM, still the data and your keys and everything is there. If tampering is detecting, memory will be malfunctions. So how did you do this, guys? If they find that you are trying to tamper with the data exists in the, exactly. So tamper move, you cannot really modify. Okay, so if they find out you are, if they found out you're trying to modify this data in the memory, what will happen? The whole memory will be malfunction. It will not work. Okay, well, that means your device also will not work, and the whole operation will stop. So even if someone trying to be manipulating your keys or accessing your keys in a normal way, the whole memory will stop to work. How they implemented this, guys? The covering component with a specific, I would say, material is called epoxy. Okay, thin wires covering sensitive components, and this is if this tamper, if you detect a tampering, these thin wire, guys, will be burned and your memory will be corrupted. So this is a way to really store the keys in a very sensitive information, and that's why SCSM is very expensive, because they're using all this very expensive technology. Okay, guys. I think right now, I'm really sorry. We have especially a little bit of the areas that we really need to cover. This is some sort of HSMs. Okay. This is how to do backup and restore. This is a full HSM scenario. Okay. And then we're gonna look at the TBM. Okay, this is the TBM is a ship and a process. Okay, I will think that it's you guys can read this last part of the lecture, and if you have any questions, we can really talk about it later on Sunday. Okay, guys. I know that right now Abir mentioned to me that you guys have a meeting with SDA, so I don't want you guys to miss the meeting, and I don't want you to blame me for missing the meeting. So I hope you guys enjoy the meeting, and inshallah I'll see you in the afternoon session or on Sunday. Yes, Lamia, go ahead. Okay, Lamia, anytime. I'll try my best, inshallah, to remember that to provide the lectures before we start, inshallah. Okay, great. Anytime, Lamia. Okay, guys, I hope you enjoy your day, and I'll see you later on, inshallah, afternoon with Dr. Asad Lab. Have a great day. Say hi to Sahar in my behalf.